Hi, in this video tutorial, I'm going to be reviewing some of the terms and concepts and skills that were covered in this SQL chapter. This will serve as your lab exercise, so please follow along and build the SQL commands as I demonstrate them in the video. We're going to be using the FACT database. FACT stands for Free Access to Current Technology. It's one of the databases that was included in the student data files, but don't use that version of it. I made a couple of small tweaks for the purposes of demonstrating these SQL techniques. So please use the version of this FACT database that I've linked in the lab instructions. All right. All the examples that I'm going to be doing, as you can see, are going to be in the Microsoft Access environment. So we'll be using Access for our building our SQL commands and testing them out. The author did a great job of providing Access databases for all the examples that were given in the textbook, as well as databases for related to some of the exercises at the end of the chapter as well. Here's our SQL exercise. Write the SQL code required to list the book number, book title, and book cost of all books whose titles start with database. Sort the results by book number and assume case sensitivity. All right, so that's what our challenge is for this exercise. And you'll notice in our book table, in the book title attribute, looking for titles with the word database in it, that there's mixed capitalization going on here. So case sensitivity comment comes into play here. We'll need to use some special operators to help us find the books, and we're going to need to use a string function as well to handle that case sensitivity. We need to sort by book number. All right, so let's get started with the select clause of this. All right, so based upon our problem statement here, write the select clause for this SQL statement and put me on pause. Let's come back and compare notes. So hopefully your select clause looks like mine. I've used all caps. It's pretty standard practice to do that. Some databases actually require it. Some databases allow you to use lowercase. But I think it's a good idea to be as exact as possible with being consistent with how attributes are named and tables are named. Now, if these were done in all lowercase, I would have followed that. If it was mixed case, I would have done that. But since it's all caps, then I'm following along with that. Next clause is our from clause. So where do we take these attributes from? Put me on pause, write it, come back, compare notes. Well, as we saw with Access creating that stub SQL command for us, we want all of these attributes to come from the book table, so that one's pretty easy. Now we get to the fun part. We want to pull out book titles that start with the word database. So why don't you write me the where clause that you think will work with that, and then we'll come back and compare notes. Do you have something like this written down? Maybe you didn't. Maybe you did something a little bit more elaborate. That might be okay, but I'm going to use this just to walk through some of the pitfalls with going about it this way. But before I can do that, we need our last clause, which is the sorting. We want to sort by book number. Write me the clause that does that. Let's put me on pause, come back, compare. So the order by clause is the one that does the sorting for you. And book number was the attribute we wanted to sort the results by. So there is a stab at the SQL commands required. Don't forget to terminate your SQL commands with a semicolon. Let me pop these into the SQL for the database here. And to do that, we want to start a query in Microsoft Access. And we come up to the Create menu up here in our database, and we pick Query Design. And that puts us into what's known as a query by example format that Access is famous for. But we ultimately don't want this. We want to work in the SQL code window. But first, before I do that, I am going to pick the table that I want from this view and pop that in there, because you'll see an interesting thing happen if I do that. And then to get into the actual SQL view, you can either come up here to this view option and pick SQL view from that drop-down list, or come to the bottom right corner once you're in the query tab. Now you won't see it if you're in the another database object tab, but if you're in a query tab, you'll see the SQL button down here in the bottom right corner, and popping that in starts the SQL commands for you, and it populated the book table in there since we had selected that. Okay, well, with that, I am going to actually just take everything out of my notepad, which I'm using as kind of a code bench, and popping it into here. You can work straight in these query tabs as I work through these exercises. I just like to show you the table or tables as we're working through it, so you can kind of see the attribute names and some of the things I'm going to be talking about. So we pop that all in there, and remember, your where clause may look different than mine, and this where clause we have constructed it to be where book title equals database. And if I run this, we get no hits, and that certainly is not what we want. And the question is, why did we get no hits? What was it about this that yielded no results? Well, with an equals sign here, it's going to literally look for a book title that just has the word database in it. And of course, none of these titles have just database in them. So that's part of the problem. So you might say, hey, Chris, I remember reading some cool little wildcard characters that were covered in the chapter. And for Access databases, they use characters of an asterisk for any number of characters and a question mark for a single character. That's noted on page 278 of your text. So you might say, okay, well, then we really wanted titles that started with database and any number of other characters that followed. So I'm going to use that feature to make that happen. Now, I'm noticed now, because I switched over to the book tab and then came back to query, I'm no longer seeing my query options, and that's because they're now up here in this design tab. I've got to click on that so I can hit my run button here. And if we do that, boom, no hits as well. And again, why did that happen? Because literally it's looking for a title that says database where it's equal database and any characters. Well, no, the titles have a variety of different characters that follow the word database. So that exact match is never going to happen either. And hopefully you picked up on the fact that in the chapter, one of the special operators that was mentioned on pages 277, 278 was the like operator. And that's what we want to use here. So I'm going to get rid of that equal sign and replace it with like. All right. And we'll try. What that's saying is where titles start with the word database and have any other characters that follow. So it's like this. but not exactly literally an asterisk afterwards. And so if I hit run, lo and behold, I get my 2 hits. And one of the reasons for choosing this database, of course, is that we can easily check that answer by reviewing the table records there. So we got our correct results. And notice how we were able to pull up both the mixed case and all case options of that database word. That may not always happen with other with other databases and other SQL servers. So I think it would be good form for us to really apply this assumed case sensitivity scenario where for a given attribute, if we have mixed case like we do in the book title here, the common practice is to take the text that is in that attribute and make it all uppercase. And then we have a consistent way to check that string of text against what we're expecting. So the way to do that, string functions are handled on page 308. For Microsoft Access, it's uCase is the string function that will take text in an attribute and make it all uppercase. And because I did it straight in Access here, I got to put my like word back in there, and I got to put my special operator in there. So that's what it should look like to handle that. So let me take that line and pop that in my SQL. And then we will run that. And you'll see it makes no difference here. Access is more friendly than that. It'll take them either way. But I think that that's a good feature that you should be mindful of and a good habit to get into. So that's exercise number 1. What you'll want to do is save this query at this point. I would recommend right-clicking on this query tab, picking save. It's going to prompt you for a name, and I would go ahead and do what you're used to doing with your initials. We could call this Lab Chapter 7 Q1 for the first query here, and that will save it in your database. All right. Okay, here's our second exercise. Suppose we want to find out which authors contributed to which books from our database. So looking at the books table, we don't see anything about author in here. So we know we're not going to be able to do that just from looking at a single table. This is going to involve multiple tables. And here's our problem statement down here. Using the author, book, and rights table, we want to write the SQL code that will join author and rights tables using the AUID as the common attribute, then join the book table using the book number attribute. Display those attributes shown in the results presented in the figure below, sorted by AUL name. All right. Well, these are the attributes shown in the figure below, and I will do this in the lab instructions document that I'll be linking. You'll see what the results should look like for each one of these exercises so that it will help you to know that you did it right. And the author does a pretty good job of doing that with some of the review questions too. Not review questions, but the review problems. So we want the author's last name, first name, book title, and book year as the fields or attributes that we want. So why don't you go off and write me a select clause that includes those attributes, just the select, all right? And then we'll come back and compare notes. Okay, hopefully your select looks similar to mine. you'll notice that I did something here just to talk about it. I prefaced the attribute with the table name, and that is optional. It's a good practice if you're dealing with lots of tables, and especially if you're dealing with tables that share a common attribute name, to specify which table you want to pull that attribute from. But if we're dealing with tables like these, where these attribute names are not shared between the tables, you don't need to have them. So I included them for author just so you can see what that looks like, and I left them off for the book attributes, and that's all good for the time being. When we get to the join conditions, that's going to be maybe a different matter. But speaking of joins, as we saw, we cannot get this information, namely the author information, from just the book. So if I double click on my author table to take a look at the contents of that, we'll see that we have the author last name and first name, which we do want as part of our output, but there's nothing about book in here. But there is an author ID. And in the book table, there is a book number. And you would correctly guess that those are primary keys for those two tables, but they're not related directly. And that's where the rights table comes in, which is our bridge entity, right? Containing both the book number and the author ID to give us that relationship. If we go to the database tools and go to relationships, we'll see those relationships that exist between author and rights through the author ID, and between book and rights through the book number. Okay, so coming back down here to our description, I've given you what you need to do without really giving you the why in this situation. Now I've just explained the why, and that is you need to write now a from clause that's going to use a join condition. It's going to join the author and rights table using the AUD as the common attribute, and then it's going to join the book table to the results of that previous join between author and rights using the book number attribute. Because remember, book number is also included in rights. So that will allow us to be able to bridge all three of these tables to get the resulting data that we want. So see if you can write that from clause dealing or using the join conditions as mentioned here. Two caveats. Because it's Microsoft Access wants you to use the words inner join, not just join, for a join on syntax. So inner join on type of syntax. And then the other thing that Microsoft Access wants is it wants you to use parentheses to group or stage the joins. So you will use a parentheses around the author and rights join that you're doing, and then book will be outside of those parentheses for the last join that you're going to do. So see if you can use the examples in the textbook to help you craft this. Just replace wherever you see join in the examples and that you're using inner join instead. All right, and we'll come back and compare notes. And why don't we just focus on the first join here with the author and rights, and we'll compare notes on that. Okay, so I've put my first join operation within the parentheses. Remember, it's going to be table, inner join, other table, on, and then you specify the attribute that they have in common. And here is where it is critical that you put your table name in front of your attribute name. So you are clearly specifying that you're using attributes from two different tables that you want the database to relate. So that is that stage. Now we're ready for the second stage, joining the book. Now all we're going to do here is we're just going to we're going to take this as one input and we're going to interjoin it with the book on and then what the common attribute there is, okay? So go off and build that and we'll compare notes. All right, so here is the second join operation. Remember, with the join operation, it's table, join other table. We're using interjoin because of access. So this all resolves to a set of records as if it were a table itself. So this is treated like a table, interjoin on other table, using or on is the syntax, and then the attribute that book has in common with rights, which was included in the record set here. So that is our complete join clause now in our from, and the last bit of business is to sort it by author last name. Do that, and we'll compare notes. Order by again. Did you remember your semicolon at the end? So that is our SQL syntax. Let's pop that into our access query and give it a run, see how it looks. All right, so it's popped in and we'll give her a run and see what the results are. Awesome. So we're sorted by last name. We've got 25 records. Interesting to note, if you come over here to the book, you'll see there's only 20 books. So why would our query result in 25 records? Why not just 20? And that's because you can have multiple authors contributing to the same book, right? Java First Steps, Paulson and McGill both were involved with that textbook. So that's why we ended up with 25 on our record set results. Okay, let's move on to the next one. And I'll remind you again to save this query out as our second query exercise before moving on to the next one. Exercise 3. Suppose we want to see a list of books that have been checked out. In our fact database, we have a checkout table that keeps track of all the books that have been checked out, checked back in. And if we want to see a list of those books that have been checked out, it might give us a sense of which books are really popular, which ones aren't very popular, that kind of an idea. So if we take a look at our checkout table here, we'll see that we've got a primary key with a number attribute. But for a given, and this is like it's like an invoice, if you will. You know, this is a record of the checkout, and the checkout would involve a book. But of course, books, the book number. But of course, books can be checked out, checked back in, and then checked out again by somebody else. So it's not surprising to see the same book number listed multiple times. Well, we don't want to see these duplicated. We just want a unique listing of each book number that has been checked out. All right, and so we're going to take advantage of a special feature to do that. And as can be seen in the problem statement prompt, distinct is the key word here that we're looking for. So page 255, take a look at that, see if you can write me the SQL code that would generate a unique or distinct listing of books that have been checked out from the checkout table. Let's compare notes. All right, how did you do? The distinct keyword is placed before the attribute that we want to be unique. We're only dealing with a single table here, and we wanted to sort it by the book number, semicolon, pop that into our query window within Access, give her a run, and there we have it. We've got 13 books that have been checked out. So we now know which ones of these. Of course, we could get more fancy and find out how many times, but that's for another class. So anyway, that's quick and dirty with number 3. Save that one off. We'll move on to the next one. Okay, in this exercise, let's say we wanted to validate. No, let me back up. So in our checkout system for this library related database, faculty are entitled to a 14-day return policy. Students are only entitled to a 7-day return policy. But let's say we wanted to validate that that was really being enforced in our database system. So we're going to use a validation technique that was similar to what was discussed in the chapter to make sure that we're seeing that 14-day period properly. That's going to involve some data arithmetic from the chapter, as well as we're going to be using the join operation from skills from the second exercise we did, and the like operation that we did from exercise 1. So we get to combine several different elements into this particular exercise. So we have our problem statement here. We have a checkout and patron table. So checkout you've seen already, patron you haven't. You see here that each patron, considered a customer, has an ID number, a last name, first name, and then their type. And this is what we're going to need to key on to make sure that we're only pulling records for which the patron is a faculty member, to compare that, in fact, the check due date attribute here is properly listing a 14-day period from when it was checked out. You'll notice that some of these entries have 14, some only have a 7-day, right? So this one should be a student, this one should be a faculty. We're going to try to validate that in this exercise. So given you the instructions here, you're going to need to join the checkout and the patron tables using the pat ID common attribute. Let's take a look at the relationship here. Checkout and patron. We can see patron has a primary key of pat ID, and checkout has it as a foreign key. So that's our relationship there. Coming back down here, then we're going to filter our results to only show records where the pat type is faculty. So we'll have a where clause, and we'll make use of that skills that we did in exercise number 1, looking for pat type of faculty. Our attributes that we want to retrieve are patron type, checkout date, the check due date, and then a calculated due date. All right. So you'll want to refer back to column aliases and how we handle those in creating these new attributes or columns that we're creating. And let's start with our select. So let's see if you can build your select clause based upon what we have, which means that you're going to need to do a little bit of that date arithmetic here when creating your alias attribute column. Let's give that a whirl. See if you can, how you do. Okay, so here's our select statement, and you'll see that our calculated field attribute is going to use the checkout date attribute and add 14 days to it. This will get us close enough. I'll explain that in a moment, but we only want to see records. We want to compare the records that are coming back from the faculty. We want to compare their due dates with 14 days after their checkout date. See if they match. And then here's our alias that we're going to use for this calculated field using the as keyword. Next step is to do our join in our from clause. So we're going to join checkout and patron tables using the pat ID as a common attribute. So see if you can write that from clause. Come back and compare notes. Since we're only joining 2 tables and not 3, we don't have to use parentheses because we're using access. It's inner join, not just join. And then we're making sure to use fully qualified attribute names by providing the table names to definitely differentiate which of these pat ID attributes we're using. So now it comes to the point where we only want records where the pat type is faculty. So we're going to assume case sensitivity here like we did in the previous exercise. And so let's write a where clause where the pat type is like faculty and handling case sensitivity. So just like in exercise 1, uCase on the pat type field and using the like and then faculty. No wildcards here because there aren't other characters that are used, but we want to handle the fact that we want it to match our uppercase that we've handled on the field. It will work if you use just an equal sign here too. Last bit, we want to handle sorting by the checkout date. So write the order by clause for that. And there's our sort by checkout date. So we could take all of this down and put it into our query window and give it a run and see what happens. Bingo. So you can see we've got the mixed case coming up, so we've accounted for that. Checkout date, due dates, calculated date. We see that's a match, 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 and then we have a mismatch here of a day, and all of our April to May related transitions are going to have that because there's only 30 days in April. And yes, we could write the SQL code that would test to see if we're in a month that has only got 30 days and not 31, but that is way beyond the scope of our work here. So we're going to call this good enough to ensure ourselves that we have applied the 14-day rule to faculty and no students appear in this list. So go ahead and save that query out as your 4th exercise, and we'll move on to the next one. Okay, in this exercise, we want to write a query that will add up the cost of books for a given year. So we want to get a total for the books in 2014, a total for the books in 2015, and a total, so on and so forth. All right. So we want to use some aggregate functions that were discussed on pages 284 to 288, namely sum. We're going to be summing up the book cost column or attribute and the group by option to have us group or total within a given set of records. So we'll use a kind of a delimiter attribute, the book year, to determine when the database should stop summing the book costs and start over again. And that we'll use that for the book year. So go off to those pages, re-review them, see if you can write the select clause that would do the summing of the book cost attribute. You're going to need to create an alias for this summing of the book cost attribute that you're going to do. So look for that as well, and then we'll compare notes. Okay, so this is what it looks like to use the sum function in SQL, and we're specifying the book cost attribute, and then we give it an alias name to be presented in the output. I've thrown in the from clause because it's trivial. We're just doing it from the book table in this exercise. And now comes the next tricky part, which is how do we tell the database that we want it to sum the book costs only for a group of records? And that's the group by clause that was also in those pages. So go review that, write the group by clause, and we're sorting by book year. So write the order by clause, and let's compare notes. So that's how to write the group by and order by clauses for this. We are ready to put this in our SQL window and give her a spin. Brilliant. So for 2014, the total of all the books is 139.90. 2015, 2016, and 2017. And if you went in here and crunched the numbers yourself, you'll see that that is accurate. So there's that exercise. Go off and save that one, and we're ready to move on. This next exercise is also going to be very short and sweet. We want to write a query to count the number of patrons. Count is a very popular, frequently used aggregate function. And of course, we can see from the patron table how many patrons we have, but, right, the typical user of the database, we don't want to show them the database table view. This would be a SQL query that would be done so that the answer could be derived without having to look at the data sheet here. So let's see this page 282 of the aggregate functions. Take a review of that. See if you can write the select, the complete select command, SQL command to do what we want to do here. I think it's good form to use an alias for your count of the attribute values. So go do that. Let's compare notes. Just like that. So I want to show you one of the reasons to get in the habit of using aliases when you are manipulating attributes through arithmetic or aggregate functions or the such. In Access, when an alias is not used, it gives you a lame column heading of expression 1000, which is pretty meaningless. So good idea to use aliases with when you're manipulating attributes. Okay, let's move on to the next one. All right, our next exercise is to write the SQL commands needed to count the number of books with a value of more than $100. So again, working with count, but this time we'll have a condition, a where condition to apply to this. So let's see if you can write the complete SQL command to make this happen. We're going to be using the book cost attribute, comparing that to this $100, and examples are on page 282 with using relational operators as well. Let's compare notes. All right, does your SQL look like mine? Simple comparison here using a greater than, and we can go ahead and pop that into our SQL window here and give it a run. It says three books over $100. Well, there's one, there's two, there's three. Looks good to me. Call that one done. Save that query off. Ready to move on to the next one. And this will be our last exercise. Woohoo! And we're going to take a look at the checkout and other tables again. Suppose we want to see certain information about each checkout that has happened. Specifically, we want information about, I'll bring this in here, book title, the book subject, the patron's last name, first name, whether they were student, faculty, and the checkout date. Those are the fields that we're interested in seeing in relationship to our checked out books. Now, the checkout table, of course, lists some information about that, but this is meaningless. This would be something you would do when populating a form for a database user. You're not going to make them go into these data sheets and cull out the different pieces of information from all these separate tables themselves, right? They are the ones that are picking what they are interested in seeing and from what tables, or what information that they want. You're the one that's building the SQL commands that are going to be necessary to give them the information they need in the way that they want to see it. So that's what this exercise is about. And we're going to need to work with three different tables to get those different fields to appear in the results. A book, checkout, and patron. If we take a look at the relationships between book, checkout, and patron, we see that book and checkout are related through the book number attribute, and patron and checkout related through the patron ID attribute. So that's what's going to allow us to get the appropriate records out for this. So again, the instructions have been given as to what you need to join. Since it's three, remember you're going to build, use your parentheses, build your first join, and then outside the parentheses you'll have your second join using the patron table. So use your previous exercise experience and see if you can build the complete SQL command to make this happen. We will come back and compare notes. Okay, this is what you should have with our select clause and the attributes that we wanted to see. Remember to use the parentheses, inner join, because we're working with access here. So we're joining on book and checkout using the book num. Remember to fully qualify the attributes there by prefacing it with the table name. And then we now join that result on patron using the pat ID, which was the common attribute between the checkout and the patron tables. Sort by book title. And we'll take that and pop it into our query window and give her a spin, and there you go. All right. You'll notice that 68 records came up. That means 68 checkouts happened. If you go to the checkout table, you'll actually see, yep, 68. It's just that we're pulling different attributes from different tables to help this be more meaningful to the user of the database. All right. So I hope you found that helpful. That's our last query. Save that one off and submit your results to me for this lab. Should also help you a lot with the upcoming assignment too, as you'll have very similar exercises to do. So good luck.